begin on right triangle trigonometry, and what we want to look at here first off is if we have a right triangle, what we're going to look at is based on this angle theta. The opposite side is the side that is not touching the angle. So the angle is made up by these two sides. The only side left is the opposite. The hypotenuse is always the one across from the right angle box. And that means the last side that's left is the adjacent side. And what we're going to use is SOHCAHTOA to remember what sine, cosine, and tangent mean. Sine, so means opposite over hypotenuse. S-O-H, sine, opposite over hypotenuse. Cosine, ca, C-A-H, adjacent over hypotenuse. And tangent, opposite over adjacent, TOA, T-O-A. Now, to get the flip, the cosecant, secant, cotangent, the reciprocals, all you do is flip it around. So the flip of sine, hypotenuse over opposite now. Same with secant, hypotenuse over adjacent, cotangent, adjacent over opposite. All you have to do is flip the one directly across from it. So how are we going to use that? We need to find the 6 trig functions of theta. So let's first just identify what they all are. If here's theta, that means this is the opposite. That means this is the adjacent next to it. And then this over here is the hypotenuse. So let's look. Sine is SOH, opposite over hypotenuse. The opposite is 12. The hypotenuse is, well, it didn't give us a hypotenuse. Well, we can find that, though, with Pythagorean theorem. If I have a leg which is 5 squared, a squared, b is 12, so 12 squared, equals c squared. So this is 25 plus 144, which becomes 169, is equal to c squared. So to get that by itself, I take the square root of both sides and get 13 for c. So my hypotenuse is 13. So that means this is 12 over 13, opposite over hypotenuse. Cosine, adjacent over hypotenuse, so 5 over 13. Tangent is, excuse me, opposite over adjacent, 12 over 5. Then to get these three, I just flip them. So instead of 12 over 13, it's 13 over 12. Instead of 5 over 13, it's 13 over 5. And then this one becomes 5 over 12, just flipping it around. In this problem, notice again, here's theta, so opposite comes down here. So this is my opposite. This is my hypotenuse because it's across from the box. And then that means this one left that I don't know is my adjacent. So how can I figure this one out? Well, this is a leg. It's an unknown as a leg, so I have to leave it as A. B is the other leg, which is 24, and it should equal my hypotenuse, 25 squared. So this becomes 625. This becomes 476, and I don't know what A squared is. I subtract this over, I get A squared is equal to 49. That means that I get A is equal to 7. So the adjacent side here is 7. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then flip them around for the other way around. Alright, now what we're going to use these for is we need to be able to find missing sides and angles by more than just Pythagorean theorem over there. So, this is how we're going to do that. First, always start with an angle that you're given. Based on the angle, what two sides do I know? Well, this is the hypotenuse. This is the opposite. So with O and H, the trig function that deals with O and H is sine. So that means I need to be taking sine of something. Sine always has to be taken of an angle. Sine of what? Sine of 32 degrees. Equals my opposite, which I don't know, over the hypotenuse. I just need to now solve for my unknown, solve for x. Well, to do that, I just multiply both sides by the bottom here, 18. So that means 18 times sine of 32 degrees is equal to x. Do I know what sine of 32 degrees is? No, but I can plug it into a calculator, multiply it by 18, and I will get a side length. 9.54 is my side length. All right, for this one down here at the bottom, same idea. Here's my angle. I have the opposite here, and I have the adjacent here. So what trig function deals with opposite and adjacent? That's tangent. I always take tangent of an angle equals, okay, opposite over adjacent, 6 over x. Now here's the issue. X is in the bottom. Well, the shortcut to do this, to get x out of the bottom, would be to multiply by x, so it would come over here, then divide by 20. Here's the trick. The x and the angle just switch spots. One's in the bottom, one's in the top, across from the equal sign. I can just literally flip-flop them and read it as x equals 6 over tangent of 20 degrees. And I can just type that right into a calculator. 6 divided by 20 degrees gives me 16.48 for my side length. All right, the last one's finding an angle. It starts out the same way. Here's my angle, I have an opposite, and I have a hypotenuse, so I'm going to do a sine here again. Sine of what? Always sine of an angle. I don't know what the angle is, so I'm going to call it theta. Equals opposite over hypotenuse. To get by itself this angle, I need to take the opposite of whatever I'm doing to it, which I'm taking the sine of an angle. Well, sine, it's not like you can divide by sine. You're not multiplying right now. That can't happen, so don't even try it. The only way to do that is with an inverse sine operation. Sine inverse is how it's written. What happens here is the sine and sine inverse cancel each other, and I'm left with punching into a calculator what is sine inverse of 5/9. And I just plug that right in using the second sine function, and I should get 33.75. Theta is an angle. That's an angle in degrees right there. If I was in radian mode, it should come out as like 0.9, I think, radians, just so you can have kind of an idea, or it might be a little bit more than one. It might be like 1.1, something like that. But right now we're thinking degree mode, so make sure your calculator is in degree mode. Same here, I have a hypotenuse. This one is next to the angle, so it's adjacent. So I'm going to be doing cosine here. Cosine of my angle is equal to adjacent over hypotenuse. Again, I get rid of it by doing the inverse trig function, so cosine inverse. And when I do that, I should get an angle of, or a theta equaling cosine inverse of 4 over 18, which I'll plug into my calculator, and I should get 77.16 degrees. So there you have it, your use of SOHCAHTOA, and be prepared to make it more intense with, of course, our lovely word problems. Have a good night.